Okay, here's an introduction to chapter 1, section 2, 1-2. We're talking about specifically about segments today. Segments, again, are part of a line. So, for example, if I took a line that went on forever and ever and ever, and I chopped it off between 2 points, this is now called a line segment, part of a line. We're going to talk and we're going to find length and midpoints, or we're going to use midpoints and other points to find out how long line segments are. So for example, if you are over here at point A and the mall is over here at point B, what can we do to try to figure out how long this line segment is, or how far away you are from the mall? So in algebra, you guys started using number lines where you could just count using addition and subtraction to count and see how far away 2 points are. And that's pretty much the first thing we're going to be doing in geometry. So we're going to use points and coordinates to do that. So the first thing I want you guys to practice, go ahead and title this number 1 on your notes. Let's say we wanted to find the length of line segment ZY. You could literally just count on a number line, but I want you to try to challenge yourselves. Would we be using addition or subtraction in this case? Well, we have a -3 over here and a 5 over here. We're going this way. It wouldn't make sense if you wanted to test it out. Well, okay, let's see. If I added it, -3 plus 5, that would be 2. This looks a lot longer than 2. So, okay, what happens if we would subtract it? Well, now we're going to get -8. It doesn't make sense to have a negative distance or a length. It would make sense to say that the mall is -8 miles away from you. So what we're going to do, but it does look longer, right? It does look like it is 8 units. That's because you need to take the absolute value of the -8. So the length of line segment ZY is 8. On your notes, go ahead and title it number 2. I want you to try to find the length of line segment XZ. And you can pause the video if you need more time to do that. So we just talked about, under our vocabulary, we just talked about distance and we talked about length. They're synonymous, and something that's important is that they are always going to be positive. Moving on. Let's talk about congruent. We're not talking about construction yet today. Sorry, guys. Let's talk about what the word congruent means. We use this word a lot in geometry. Congruent means pretty much, a lot of people like to think that it means equal. Congruent segments are segments that have the same length. Okay, so congruent, we're talking about actual things, actual physical things like line segments. It's very similar to equal. We use equal signs when we're talking about numbers. We use congruent signs, which is an equal sign with a little tilde, when we're talking about things. So since a line segment is a thing, we're going to use the congruency sign. This right here is a sentence in math, and it says line segment PQ, this means line segment, is congruent to line segment RS. So rather than writing that out in English, it's easier to write it this way. In pictures, we use tick marks to show that two things are congruent or are the same length. So this tick mark right here, this red thing, means that this line segment PQ is the same length as this line segment RS. So that's cool. You don't even need a ruler. You don't need to trust, you don't need to like measure it. You can just trust the tick marks. And which is good, because in my class, I have to draw a lot, and my pictures are never to scale. So for example, let's say I give you 2 more line segments, and I wanted to show you guys that these 2 line segments that I just drew, line segment AB and line segment CD, I wanted to tell you guys that these are congruent, but are not the same size as these ones. Well, to do that, I would still use tick marks, but if I put 1 tick mark, you would think that all 4 of them are the same. So what I'm going to do is I'm going to put 2 tick marks. Okay, so however many tick marks, the things with the same number of tick marks are the same length. That's what congruent means. Let's talk about another vocabulary word real quick, and that word is between. Between. I know you guys have used that word a lot, and it's hard for me to describe, so bear with me. I'm better with pictures. So let's say, for example, I tell you this. I tell you that point G is between F and H. Okay, well, here's F over here. Here's H over here. They're all on the same line. That's implied. And G is somewhere in between there. So I'm going to put it over here. And some of you guys are going to put it right in the middle. I don't want you to put it right in the middle. Between does not mean middle. And I would definitely write that down. It is not in the middle. Once you have it here, you're going to fill in the rest of the picture. So it says that segment FG is 6. units long, so this one's 6 units long, and that FH is 11 units long. So here, this part is 11. And then they want you to find out the missing piece. Well, this whole thing is 11. This part is 6. You guessed it. All you're going to have to do is subtract. And so that means that the leftover piece is going to be 5. So you're either adding or subtracting, which is nice. And there's a name for this, and this is really important. The name for that is called the segment addition postulate. Definitely write this down. We will use this in proofs. So segment addition postulate, lucky for you, it's not a fancy schmancy name. Segment, that's what we're talking about. We're talking about line segments. Addition, we're talking about adding two different parts together to get the whole line segment. And postulate, we can talk in class about what the word postulate means. It's just a fancy schmancy word for something that's believed to be true. So basically what the segment addition postulate is what we just did. If I told you that B is in between A and C, and I told you that line segment AB is 1, and line segment BC was 4, well, I could take these two pieces, add them together, and that would give me the whole line segment AC, which is 5. Okay? So we're going to be doing that. That's a simplified version. Here's a harder problem that we're going to be doing in class. So why don't you go ahead and try that on your notes and title it. I think we're on number 3. Okay. The last thing we're going to talk about today is we're going to talk about the midpoint and bisect and segment bisector and congruent segments we've kind of already talked about. These 4 words are kind of all talking about the same stuff. So midpoint, I bet you guys could guess it. Mid kind of sounds like middle. Point is a point. So a midpoint is something that's exactly in the middle of 2 other points. So to show you that B is the midpoint of line segment AC, you would use tick marks. So when you see the tick marks, that means B is exactly in the middle. You could also say that B bisects line segment AC. To bisect, it's like a verb. That's the thing that's actually doing the cutting. So it's a verb. Midpoint, whereas midpoint is a noun. So B is the midpoint of AC. So these are really just saying the same thing. And a segment bisector is a segment that bisects something else. So segment, like we talked about, this part, AC, would be a segment. And if I went like this, that would mean that this segment AC is bisecting something else. Okay, so how that comes into play was what we were just doing before. It's similar to the between part, but just a little bit different. So for example, let's say I give you this problem. This is the last one. I think this is number 4 for you guys. So it says D is the midpoint of EF, of line segment EF. Whenever you see this word midpoint, you get to do tick marks. Yes, awesome. So this now we both know that this part, DED, is congruent to DF. That means that this part is going to be equal to this part. So all you have to do is set them equal to each other and solve. And this is just what you did in algebra. So you're going to solve for x. But the biggest mistake that geometry students make is they don't go back and they read the question. They do their happy dance, they solve for x, they're like, boom, I'm done. No. In geometry, I'm actually asking you to go beyond just solving for x. You have to, once you know what x is, go in and plug it in and tell me how long ED is, how long DF is, and how long EF is. And that's what we're going to be doing in class tomorrow as well. And I want you to go back really fast. Just make sure you know all the vocab questions that are all the vocab terms that we went over today, and be ready for tomorrow's discussion.